All right, welcome everybody. Thank you for joining us today to learn more about moving data to the cloud. I'm James Green. I'm with Actual Tech Media, and I'm going to be your moderator today. The presentation and demo we're about to do here is from one of my favorite big data companies called Panoply, and they have created what they call a data management platform, which I think is really cool. And so we're going to be learning some more about that. Before we get started today, I just want to make you aware of a couple of things that you'll need to know as we go through this event. First of all, if you look in your attendee panel, you'll see that there's a questions area where you can submit a question during this event. And I want to encourage you to make liberal use of that because as we get towards the end of the event, Yaniv and I are going to take some of your questions and we're going to talk through them. So anytime you think of something, make sure and pop that in there. We'd love to chat about it later. Second, you can see here in the handouts section of your panel that you can download a handout we've put in there for you. That's free and that's great content that they've provided. And so you should definitely download that and take a look. And lastly, as I'm sure you're aware, we're going to be doing a giveaway at the end of the event. And for that particular giveaway, it's going to be a $300 Amazon gift card today. So stick around for that. Anybody who's here for the entirety of the event is eligible to win, and I hope you do, so stick around for that. Now, without further ado, I'd like to introduce the speaker for today's event. We're fortunate to have with us one of Panoply's co-founders, actually, and their CEO, Yaniv Levin. He has an extensive IT background, especially in the analytics space, and that makes him especially well-suited to lead a big data company, so this is going to be great. He's going to walk us through the Panoply story and present an argument for, as you can see on the screen here, why not use both data warehousing and data lakes as we're considering the architecture moving forward. He's going to present an argument to us for why we should be able to use both. And after we get through that, we're going to actually get a great demo. We're going to see the platform and how it works, and then we'll get into the Q&A. So I'm excited. Let's go ahead and get started, Yaniv.
All right, James, thank you so much. Thank you, everybody, for joining us, whether it's late or early, wherever you are. So basically, we'll walk through this presentation. It'll take approximately 20-25 minutes. And then afterwards, as James explained, we'll jump over and see the demo. So today, basically, we're going to talk about data warehousing, data lake, and then show kind of the Panoply architecture. Basically, we'll be talking about analytics infrastructure, and more specifically about these two competing and at times complementary technologies, being the use of data lake and or data warehouse, at times a columnar database in your analytics infrastructure, basically the goods and the bads of each. And then we will also be presenting Panoply's infrastructure as some sort of demonstration of a hybrid solution. So today's speakers, I'm Yaniv Levin, the CEO of Panoply. As James explained, I've co-founded Panoply approximately 2 years ago. Prior to that, led analytics teams for basically over a decade, developing proprietary models around B2C industries. And joining me is Alon Brody. Alon is our lead data architect. He's a known data engineer with over a decade of experience in various warehousing technologies, with past experience in development of proprietary storage technologies. So kind of going through the topics that we'll talk about today. So there's a broad range of knowledge here in the audience, so we'll begin with setting the groundwork with some definitions and understanding what these technologies are all about. After that, we will discuss some of the differences, talk about samples of the lake and warehousing infrastructure, and then demonstrate Panoply's infrastructure. We will answer some questions along the way of the presentation, and we'll leave some room for Q&A towards the end. So I hope that kind of gives some structure to our talk today. So let's begin. So perhaps the biggest move in the past decade has been from the kind of ubiquitous data warehouse to the rapid build of the data lakes. And while both have their pros and cons, today in the big data era, the utilization of smart data lakes seems to kind of alleviate the downside of both, creating a clear path to where the industry is going, and we'll talk about that later on. The latest talks about semantic data lakes definitely seems like the next rational step for the industry. But in our perspective, not the last word. And in the next 25 minutes, as we'll go through this presentation, we'll discuss the evolution of the warehouse to the lake and some coming trends and how we at Panoply are implementing and envisioning the last evolutionary step of where this industry is going. So the data explosion in the past decade has presented new challenges surrounding analytical data technology. It's a known fact that 80% of data is not being analyzed for value, and this is basically due to constraints around the ability to harness data for analytics. And there was an article in the New York Post, I think a year and a half ago, basically surveying data scientists, and what they talked was a survey of around 300 data scientists, and what they said is that they spend around 50 to 80% of their time around complex tasks of wrangling their data and getting it ready for analytics. Now, anyone who's ever dealt with data scientists and the art of harnessing data for analytics kind of knows why this happens, right? It kind of makes sense. It kind of makes sense because of the way current infrastructure is built today, and that is basically due to the fact that the problem of big data is not just its size. In fact, the fact that 80% of data is not being analyzed does not really mean that there is 80% of value missing. The value missing might actually be incremental or minimal, but the problem with big data is much larger than its size. It's also around the integration of multiple data sources, which have been growing at the same pace as the data size. And it's also a problem of data utilization sources, being different end users in the company wanting to utilize data in different ways. And somehow the architecture that we're all building needs to answer all of these challenges, so it's no surprise that the larger the data gets, the more fragmented its sources become, and the more needy its end users are, the longer it takes to bring data to value. And still today in 2017, and I see this happening and continuing to grow, in some cases, it's just small incremental changes inside the architecture to harness another small incremental piece of data can take months and be very, very, very labor intensive. So starting with the definitions, to set things up, what is a data warehouse as compared to a data lake? Because we at Panoply, we know, and we've actually pulled this in the last AWS reInvent, that there is a lot of talk about data lakes. A lot of talk about data lakes today. It's a hype. Everybody knows the last 2 years of the Hadoop hype, but still a considerable amount of investments is going into data warehousing. And I think a lot of it has to do with the notions that people have when approaching these technologies, which some might and some might not be true. So data warehousing or an EDW are essentially designed to solve predefined questions on a known data set. They're central repositories of integrated data from one or more disparate sources. They store current and historical data and are used for creating analytical reports for knowledge workers throughout the enterprise. What this basically means is that the typical use of a data warehouse is for data that has already been modeled or structured. So before we load the data into the warehouse, we first need to give it some sort of structure, and this is done primarily due to cost and performance reasons. Now, based on this, the end user community is very well defined. Many times they have data marks built on top of these to more clearly define the user community as a subset of the aggregated data. Now, what that usually means is that the type of questions we are going to be asking in the future are basically predefined in order to install our business logic beforehand. And in case our business logic changes, and it does frequently, we will basically need to redefine the way the data is structured inside our warehouse. So a typical way data would be stored inside the warehouse is that there would be some sort of metadata level encompassing the types of data inside the warehouse. Underneath, there would be some layer of aggregations, a layer of augmented data, and finally the raw data layer. When the company grows and users become more diverse, there is sometimes a need to extract certain universes of knowledge to data marts to answer more specific unit questions in a faster, more organized way. And this is when we basically build those data marts. Now, as the data grows and becomes more complex, companies go on to build an operational data store. This is basically a lake, right, that enables raw data to be sent and enable a kind of sandbox environment for these data scientists to feed their models and play around with, kind of a raw data sandbox. This can stay independent or feed the traditional warehouse. Now, in that same context, a staging area is usually built for more agile ETLing when the company grows and the data becomes more fragmented. So as you can see, it gets very complex very fast. It takes months to set up. It requires ongoing maintenance. It's also very, very rigid in terms of not only in terms of the architecture, but also in terms of the processes and the data itself, the data that can be queried. So every little change becomes a kind of project of its own. So the data lakes, on the other hand, basically have basically been built to address some of those challenges. They're also storage architecture, but basically much cheaper and more agile storage repositories that hold vast amounts of data. The data is usually stored in its raw form. Not only that, but any data can be stored there, whether it's like structured, semi-structured, or unstructured. You know, high level, the data lakes are a very cheap way to dump all of your data in one place while still leaving it somehow accessible for extraction of value. So some of the questions are known ahead of time when building this architecture, but some are not. It's much more agile, which basically leaves much more flexibility as to the type of use cases that can be used, and as a result, the potential users can be much more fluid. The main issue with the data lakes is that without adequate governance, data lakes can rapidly become data swamps. They're polluted with poor quality data, and this has wide implications on the enterprise and how they can actually utilize their data. So not only is will the performance be terrible in the case like this, but the end users inside the company, whoever they are, will not be able to understand the data if they're actually able to find it, right? Or find where it came from, and so on, which will eventually lead to end users not trusting the data and not using the architecture that you built. So in order to tackle these roadblocks, implementations of logic on the data lake has been applied or is applied in some sort of way, basically taking away a large part of its advantage. So companies start building ETLs and staging areas into their architecture. They build MIOs, managed information objects, which I've seen as some sort of tool in order to enhance your structure inside the lake and make it accessible. And guess what? So all these processes that are built, basically installing the data logic on top of the data lake, need to be managed, and they need to be maintained, and the garbage needs to be cleaned out, and the performance issues need to be addressed. So a lot of the advantages of the data lake, being just a dump of data where we can access it pretty easily, are kind of taken away once we have to make it usable for analytics purposes. So when comparing these two, we need to understand the basis of the comparison depicted by the needs of the company or the needs of the end user. You know, whether we're building it as a company-wide architecture or just a sandbox for data scientists. In our world, the world of analytics, unstructured data like GIFs or vids have no need. And when you assess technologies, the underlying decision point would be based on basically three parameters. One being the ease of onboarding, use, and maintenance. Two, the performance, and three, the cost. So the lake technologies have sprung up and trended mainly due to these benefits. Cost is usually much, much, much lower. Onboarding is easier, as there is no real need for crunching up the data ahead of time, while performance, at least thus far, is still subpar compared to EDW technologies. And when you want to get performance better, you have to take away some of the simplicity that that these technologies address. But if we really look at the differences in philosophy of these two technologies, the idea behind the data warehouse was to identify basically the important data ahead of time and structure it in a way that was easy for consumption by the end users. So the underlying assumption is that you basically know what you need to know ahead of time when you set the schema and aggregations. The data lake comes from a different point of view, and it comes to address these challenges by providing a more agile solution with a richer set of data. In a data warehouse, the data is structured in a row and column structure, usually held in some sort of relational database, versus a data lake that can host any type of data, even that which is not accessible for analytics, which we mentioned earlier. But the most important aspect, in my point of view, is that is the way the data is being processed. So the schema in the warehouse is applied when the data is being inserted into the warehouse, while in the lake, the schema is applied as the data is being pulled out of the lake. Basically, this is the difference between schema on write and schema on read. So the implications of this on a practical and philosophical level is that you as a stakeholder in the business are not required to know ahead of time what you're going to ask. So you're not restricted in terms of your business logic. And anybody who's ever done analysis knows that no matter how good you are and how great your people are, your engineers and your analysts are, you kind of never know what type of questions you're going to ask in the future. And there's also the argument that in a data warehouse, you lose information. Basically, having this ETL process connecting into the warehouse, the data being crunched and transformed makes the data set not as rich as it was when it was in the raw data form. Now, this argument is absolutely true. Basically, it's true, but it's not true due to the architecture, due to the warehousing. This argument is true mainly due to the ETLing process. And the minute you wrote an ETL process, you'll begin losing data, meaning your analyst will analyze the data on a poor set. Now, this argument is true, but it could also happen in the lake, depending on the type, on the way you actually build the logic inside the lake. So generally speaking, while the ease of use, its flexibility and cost structure provide a great backwind for the lake technologies, its cons regarding its performance control and integration are still stopping it from dominating the markets, even though we see these trends going forward. So basically, the traditional data warehouse were overcome with the newer MPP databases about a decade ago, and we still see these technologies strong inside in the industry. Still with a schema on write logic, but with a more seamless architecture. But the underlying logic of normalizing the data, modeling it, and building the schemas are now kind of limiting it with large volumes of data like clickstream data and sensor data and so on, which are requiring a much more agile set. So the data lakes provide much more agility, right? Specifically due to technology's ability to store more data types at a lower cost and explore the data with a schema on read logic. What we've seen, though, in the past couple of years, specifically around Hadoop technologies, is a hype to try to make Hadoop, or basically the lake, what it isn't. For instance, trying to process small sets of data, in speed. So the traditional approach of IT was to prepare an architecture for structured and repeatable analysis. This was the old approach, kind of like the architecture that was built in the beginning of the 70s and talked about more towards the end of the 80s by IBM. Basically, business users decide ahead of time what questions they would like to have answered, and have the architecture built or in the data logic installed in order to answer those questions. But today's approach in the world of big data requires the architecture to enable iterative exploratory analysis. basically deliver an infrastructure that is much more agile in terms of its ability to answer unknown questions. So the thing is, though, that at least in the architectures that I've seen in many different companies, most companies today still fail to grasp what that actually means, the meaning of agile architecture. And today there's a hype over the lake as it's going to solve like everybody's problems. And the thing is, looking at this technology the way it is today, the truth is that it's not. A data-driven organization still has to go through a manual process of months to build and years to maintain an intermediary data management system. The main reason, in my opinion, is that it's not really a problem of storage technologies and architecture, and this is what the relational databases versus the data lakes come to address. I mean, it is high level, but there are more challenges to overcome aside from where to store the data and how to access it. The fact still remains that the main challenge to overcome, regardless of what infrastructure you use underneath the hood, is a data management challenge that these infrastructure technologies will not solve, because they're not looking to solve them. They're looking to solve the storage and accessibility challenges. We'll talk about this in just a few minutes, but first let's go back to what a typical data warehouse architecture looks like. So the relational database revolution in the early 80s kind of ushered an era of improved access to the information contained deep within the data. It was kind of then discovered the databases modeled to be efficient as transactional processing were not always optimized for complex reporting and analytical needs. So the practice known today as data warehousing actually first saw its genesis in the late 1980s, as I mentioned, in IBM, when IBM published this journal around the architecture of business information. Even though Bill Inman, there was a big discussion about this, actually first talked about its principles in the 1970s. And as we said initially, in a regular data warehouse process, you basically need to know ahead of time what your logic is going to be. Basically, what questions you're going to ask. Just setting up the infrastructure takes months, and maintaining it is an ongoing project. So it's really a really slow iterative process. And in today's world, it just isn't sufficient, which requires continuous optimizations and teams of people to continuously support these data marts and the underlying storage technologies and so on. In practice, the notion of pre-modeling your data just does not work, because today's companies have various use cases, various data sources, and data gets augmented. What basically this means is that there's constant work for the data engineers to continuously optimize this architecture. So not only is it slow, but it's also very labor intensive. The data lake architecture, the data lake, basically a next generation data storage and management solution, was developed to meet the ever-evolving needs of increasingly savvy and disparate users inside the organization. It's a data-centered architecture featuring a repository capable of storing vast quantities of data in various formats. So data can flow into the data lake by either batch processing or real-time processing of streaming data, which is, it's great for industries like IoT. This set of capabilities allows IT to provide data and analytics kind of like as a service in a supply-demand model, right? Users browse the lake's data catalog to find and select the available data to fill a kind of like metamorphical shopping cart. Basically fill up their shopping cart with data to work with and then build on their models and so on. Once access is basically provisioned, users can use the analytical tools at their disposal to develop models and gain the insights that they're looking for. So subsequently, users can publish analytical models or push refined or transformed data back into the lake to share with the larger community. So it really depends on the data lake technology, but people usually think of data lakes as something that is kind of more sandboxy. But the truth of the matter is that they're usually a pretty rough start to get started with. It can get very cluttery, very, very fast, and also has data limitations depending on the structure of the infrastructure, the way you basically install your data logic on top of the lake. So what are they really, like the high-level typical use cases of the data lake today? As we discussed before, one of the key uses for the data lake technology is as a kind of data scientist sandbox to play around with for building and testing their models. Another use case which I've seen is a data library for the outside world. I've seen this in medical data companies, municipalities, the New York Stock Exchange, and so on, where they build a lake of information and allow the outside world to analyze it. Basically, allow access to the outside world to analyze their sets of data. As part of the analytics infrastructure, this is a third kind of use. As part of the analytics infrastructure, which we actually saw in the last slide, that basically enables data scientists to analyze the data and it also feeds the EDW. Basically, it's kind of used as a staging environment where the ETLing happens and then feeds the EDW. This enables the engineers to curate data in the lake with added flexibility and less data loss. Now, since the data lake is pretty much a data dump, if you treat it as such, it will also behave as such. And therefore, if you approach the data lake for the core storage basis of your analytical infrastructure, your initial approach needs to be the same initial approach as would be for building the data warehouse, basically the installment of logic. So you kind of need to understand who your end users are, what they're going to be looking for inside the data, because you will need to put some sort of indexing and implement some sort of logic on it. The data needs to be cleaned up as it goes in, and the logic installed on top of the process. And you constantly need to monitor the performance, and this is a major problem with the lakes. So to kind of sum it up, using multiple tools and products to extract the maximum value requires customized management around the data lake. Constant management of the processes, and an example for that, a data lake that needs to be tailored for one industry, just like an EDW will not necessarily be tailored towards another, right? So you tailor a data lake for a retail industry, it will not necessarily be the same use case as a medical industry. Building your logic on top of the data lake requires a business-aware data locating capabilities to know where the data came from and what it means. And that requires configurable ingestion workflows and so on and so on. So after all of this, we're still left with the question of what to use. We wrote an article about this in Panoply in our blog, and we discussed the fallacy of one technology, the idea of one technology to rule them all, and we discussed this basically around the Hadoop technologies because of the overall trends that we've seen and the hype that we've seen around the lake utilizing Hadoop. And in Panoply, at least with today's technologies, we truly believe that there's no real one technology that fits all. So at the moment, and you need to see where you are in terms of your company needs and so on. But at the moment, we just can't find a typical use case that one technology would suffice above the other. That being said, today we believe that the best scalable utilization of these technologies for analytical purposes specifically, and this is what we're about, is some sort of hybrid approach, which we'll discuss soon when we discuss the Panoply architecture. So the main reason for this is that, in our opinion, to decide where your organization wants to be in the triangle of performance, cost, and simplicity, you will need to utilize the best of both of these approaches. A data lake can basically solve many of the challenges of the warehouse by enabling low-cost storage and the agility and simplicity that the data warehouse lacks. Basically, staging areas and archiving are perfect places to utilize the lake while maintaining the relational database for the day-to-day querying. So this will not only end up with lower storage costs, but also enhance performance almost by default. Take into consideration that schema on read is great for some deep mining use cases, but for most analysts, it will be just too much and too messy. So we'll dive into the Panoply architecture and what we see as the ideal kind of architecture for the analytical use cases. But in these types of problems, I think that the most important thing is to keep your mind open and be flexible. Now, this is incredibly hard because technologies around data come up basically every week, and each one of these is cheaper and faster and better. Each one solves some specific use case around some specific challenge and so on. So it's almost inevitable that whatever architecture you decide on today will be, I won't say irrelevant, but kind of second tier in a year or two. So when we talk about analytics, and now we're kind of jumping into the Panoply use case, when we talk about analytics infrastructure, we usually talk about three main blocks of technologies and processes. This is kind of like the same whether you're a data lake or an EDW. The data management problem still consists in both cases, and it does not matter what technology you use underneath the hood. So the data management problem is what provides the need to combine different technologies for a robust data warehouse, and what makes a simple technology like a data lake so cumbersome and difficult. So the first one of these technologies and processes is ingestion. This is basically where you take your disparate data sources, mash them up together, clean them up, and streamline them into the stack. The second one is a process of management and handling, and this is where you select your nodes, make sure your architecture can scale, take care of your revision history, and so on. Basically, all the processes and technologies that need to be taken care of to ensure that you aren't paying too much and that your analysts can get reasonable time to market on their queries. And the last one is basically extraction, the extraction of the data from the relational database or from the lake or from whatever architecture you might have built to the BI tools or to the data utilization tools. And these can be BI, this can be dashboarding, this could be data mining, whatever you're utilizing in order to access your data. And this is where the optimization of queries and optimization of schema happen, and they happen quite frequently, regardless of which technology you might be using. And just looking at these two and at these slides, and kind of understanding the data management problem, where does Panoply fit in? So basically, Panoply takes the world of data management and tries to make it as seamless as possible. And we do this with a layer of machine learning algorithms that we've built above the best-of-breed technology stack, which we'll talk about in a sec. And what these machine learning algorithms do is that they basically automate the world of data management above the utilization of a hybrid data warehouse or a hybrid relational database and lake approach. So what we enable is kind of like to solve those issues around the data management problem and provide the best access and best performance for these analysts while still saving costs and enabling the store of a rich set of raw data. So how do we do this? As I said, we have three sets of machine learning algorithms that reside over the storage stack. The algorithms basically automate the three blocks of technologies and processes that we talked about earlier. They basically learn your data structure on one side and your business logic on the other side, and continuously optimize the process involved with management and handling, including the schema queries and storage costs, so that your engineers can focus on your core product. So Panoply's architecture, as you can see above, is a combination of both worlds. We utilize the lake, but in a kind of different way than the regular architecture that we saw before. We utilize the lake as in a kind of smart way, basically as part of the EDW storage instead of a staging area. All the data that flows into Panoply flows into the warehouse, Redshift in this case, but it flows into the warehouse without the loss of information because we ELT the data instead of ETLing. So the algorithms learn which data you use more, which data you use less, and then cool down the data that is used less into the lake, basically into S3. And this heating and cooling mechanism is being done in a continuous manner, so you basically get the same massively scalable, agile results you would get with a lake, but the performance and structure of a warehouse. This also enables you to get flexible schema that is adaptive and automatic, so you keep the agility you would have with a lake, but still get the power and performance of a data warehouse. What would what would be best for us right now is to jump over to the demo and show how at Panoply we kind of solve these data management problems.
Great, thank you. I'm passing control right now over to Alon. You'll just have to share your screen and then we can get into the demo. All right, I see your screen. Go ahead.
Perfect. So let's go over the platform, and what I'm going to do, I'm going to connect a couple of different data sources, and we'll actually utilize what Yaniv just mentioned during his presentation and explain what we do exactly in Panoply in order to take the advantages of both the warehouse and data lake. So here in Panoply, what we give the user is an actual data lake and data warehouse, and we allow him to connect whatever data source he wishes to connect from our pre-integrated data sources, where we have different APIs that are a few clicks away from connecting to your data warehouse, a bunch of different databases, and a few files and services. For this demonstration, let's start with a file upload, where I'll just choose the file itself, and as you can see, all I need to do is just set the destination itself, upload the file, and start collecting the data. While we collect the data, the platform actually understands what are the different fields, field types, and also relations between the current data stream and any other existing data in the data warehouse itself. So let's keep it running and add a new data source. Let's pick the Google Analytics one. So in this case, all I need to do is just Google connect to it. Choose the specific view I want to connect to Panoply. And now we have our default metrics and dimension settings, but we can also change it. I'm going to keep the default ones and collect the data. As you see, we have about 2,000 rows remaining. In the meantime, let's move over to the job screen where we can see all the history of each and every data source that we've collected. So we can see that the data source, the file upload, actually collected 7,000 rows for us. And if we'll go to the table screen, we will see both tables, both the demo data from the file upload that I've uploaded and the Google Analytics table. I can go into each and every one of them, see the sample of the data itself, and actually see also the metadata. So we can see all the different fields and the field types that we have here. Each and every one of these fields can be customized from things like removing a field, renaming, setting a description, changing the type if needed, but actually the platform will do that automatically whenever it's needed, and a few more advanced options for each and every field. In the Analyze page, we can actually see both tables. So we have the Google Analytics and the demo data table. So I've actually have a query ready for us. I'm going to use this query in order to get the top 5 countries from the same CSV file upload that I've connected. So let's run this query, and here we go. We can see that the US is leading. Now, if I want to use this specific query in the future, I can simply save it as a view. So if I'll open the menu and click on Save, I just need to give it a name. So I'm going to name it Top Countries. And that's it. It has been saved. Now, Panoply will follow this specific view, and if needed, it might transform it from a simple view into a materialized view in order to improve its performance. Now, we've connected a few data sources. We've added a business logic, the top 5 countries query, for example. Now let's connect a visualization tool. So here we have all the different details that we need in order to connect an external tool. So we have the host, database, port, username, and obviously the password. Now, each and every tool that has either a Redshift or a Postgres connections can connect immediately and directly into Panoply. And if they don't have one of these 2 connections, they probably have an ODBC or a JDBC connection. And then by using the relevant drivers for either Redshift or Postgres, you can still connect to Panoply. There are tools like Tableau, Looker, R, or almost any workbench that is out there can connect to Panoply. Let's move on to Looker. This is one of the visualization tools that we support. As you can see, I already connected it to our cluster, to our database, and I can immediately start exploring the data. So let's go to the top countries view that I've just created in the platform. And in this case, I want to create a new report. So I'm going to pick the dimension of country and the installs measure, and I can just run it. Under the visualization options, I want to change it to be a pie chart. And let's, for example, change it to be based on labels. Now all I need to do is just save and add it to a dashboard, give it a name. So I'm going to name it Top Countries. I'm going to send it to our demo space. As you can see, I already have a few reports over there. And send it as well to the demo dashboard that I've already created. Now, in the demo dashboard itself, we have a couple of different reports, the installs by date and uninstalls by date, but I just want to edit it as well, just to place the top countries report in its place as well. So I'm just going to place it over here, and that's it. The dashboard is ready to be shared with my colleagues, and they will see all my knowledge and information that I gained from building these reports, from connecting Panoply into my specific CSV and Google Analytics. Now, if we'll go back to the platform, we can follow all the different queries that run over Panoply. So by that, the platform actually identifies our day-to-day patterns, meaning which queries we run when, and which queries run slower and which queries run faster. Based on that information, the platform will know exactly what are the pain points, which tables, which fields, which views caused the slower queries to run. So based on that, it will try to change and optimize the performance by changing views to be materialized views, changing indexing, changing compression types, changing query queues, and also storage allocations between the data warehouse and data lake, just as Yaniv mentioned earlier. We have plenty of different features inside the platform itself. A lot of them are visible in the UI, such as the queries, the changing of the metadata, and so on. And some of them are also just behind the stage features that will optimize and evolve with you. As long as you keep on using the platform, keep on asking questions, the platform will optimize and be better for your specific use case and your specific data.
Great. That's extremely interesting. Do you have anything else to show here before we move into the Q&A?
No, that's basically it. If there are any questions, please, guys, feel free to ask.
Okay, wonderful. Make sure to pop into the questions box there and ask questions, folks. I've got some here that I've been collecting as we went along, and we'll start on those. But if you've got any questions right now, it's not too late, so go ahead and start popping those in there. This is for either of you, but I'll just start at the top of the list here. Kind of back towards the beginning of the presentation, and I've mentioned that when you were talking about data lakes, structured data, semi-structured data, and unstructured data. And I think that a lot of us are familiar with the conversation around structured versus unstructured data, but semi-structured data is, I think, a term that not everybody is familiar with. Can you just help us understand what that would be, or like an example of semi-structured data?
Sure. So basically, structured data, as everybody knows, is data that is fully structured, meaning a table. A good example for that would be to look at an Excel worksheet where you have definite headers and data beneath each and every one of the headers. Semi-structured things like JSONs or objects that actually hold things that are part of it is structured, meaning you have a key and value combination, for example, but each and every object inside the same, let's call it family of or collection of data, can have more or less different keys and different values, and it doesn't have to be under the same structure. For example, an address field can hold an object beneath it, or it can be a simple string or nothing at all. Where in the structured data, it must be the same, not the same data itself, but the same data type and structure. Unstructured data are things that are really more complex. Things like simple text, pictures, videos, and things like that. Things that doesn't have, you won't just be able to go and look for a specific header. For example, in a blog, in a blob of text, you won't just say, okay, I want to know the name of the author. You probably won't be able to find it, but in a semi-structured or structured data, you will have a key or a field named name or named author, and based on that, you will be able to find your answer.
Okay, great, thank you. I have multiple people asking about the pricing model. So if I want to start using your platform, is it priced based on connections, or how much data we're storing, or how does that work?
Yeah, so I'll give the short answer, but then maybe elaborate a bit more. The short answer is that Panoply charges based on it's a tier-based subscription based on the amount of storage, based on the amount of data that you store inside the platform. Now, the data that is stored inside the platform basically mean the data that is stored inside the inside the relational database. We don't charge for the data that is thrown down and archived in the lake. So that's the high-level answer. Basically, tier-based subscription based on the amount of data that is stored. The longer answer, this is a more philosophical, is that when we came to build Panoply, we wanted to build a tool that would enable analysts or data scientists, basically anyone that is in the position of extracting value from data, to be able to ask however many questions he wants, he or she wants, and with whatever capacity and to the richness and fullness of the full data. And that's why we decided not to charge based on the amount of data ingested. We don't want to stop people from ingesting data. We decided not to charge based on the amount of data that's being extracted or queried, because we don't want people to stop people from querying data. The opposite is true. We encourage companies to connect multiple sources and multiple utilization solutions in order to analyze their data. The idea behind it is that the platform grows as you grow, and it supports all of your analysis needs, from dashboarding all the way through to data mining. Yeah, I hope that kind of answers the question.
Great. I know I've got at least one person thinking about this. A lot of companies are still running an on-premises EDW and still a little bit wary of moving all of this stuff into the cloud, even if they kind of have the impression they can do it better from an economic standpoint or something like that. The security thing is still a big concern for them. How do you guys feel about making that migration and whether that's a safe thing to do and that sort of thing?
Yeah, so I think that overall, in terms of security, the cloud, and this is just specifically about security, the cloud is much better tailored to security needs than an on-premise technologies. Reason being that for on-premise technologies, you basically need to unlock one point, and then you have access to everything. Well, the cloud is by definition distributed. Second thing is that, again, in terms of a philosophical point of view, you have these companies that their whole notion, their whole business is built around storing other companies' data. So you can rest assured that they're doing everything possible in order to make sure that the data is as secure as possible. Because if it's not, for them it will take down the business. Now, in terms of migrating to cloud, I think security would not be an issue that would be of concern for me. I think in terms of migration to cloud, there would be other issues that would be concerned, which I think would be much more viable. For instance, on-prem technologies and cloud technologies are inherently different. So migrating data from on-prem to cloud can be extremely difficult. It can take years. And the thing is that after you've done the migration, even under the assumption that you saved some costs, after you've done the migration, nobody promises, and you probably won't have a way to measure, that your cloud architecture is optimized. Optimized for cost, optimized for performance, because it's kind of like comparing apples to oranges. So that would be my main concern. What I can say is that in Panoply we have thought of this aspect, and that's why the algorithms basically take care of that migration. And as they migrate the data, they can migrate the data today and not in 3 years. And two, once they migrate the data, you can be sure that your cloud architecture is optimized. And not only is it optimized, but it's optimized and tailor-fitted towards your needs, because that's what the algorithms learn, and that's what they do. So just in terms of the cloud migration, I think the optimization of the architecture, its performance and cost, that would be my main concern, not security.
Great answer. Thank you. We got one more easy one here, and then we're going to do a giveaway. Let's see here. Oh, so you talked about the different types of external tools that you could connect and the qualifiers for that if it was Postgres compatible. Is there anywhere that you have, even if it's abbreviated, but is there any list of tools that people could go look at and say, okay, if I've got one of these, then I can connect it?
Yeah, so Panoply is open on both ends. So when you talk to our reps, the short answer is when you talk to our reps, they'll be happy to give you a paper or a document which describes all of our data connectors, all the tools that can connect to Panoply. Two, on our website, there is a page which explains everything like all the ready setup connectors to the platform. But
it's important to understand that the platform is open on both sides. Basically, if there is a data connector that has not been built yet and your company needs it, it will be built, and it will be built either by Panoply or by you. You can actually build data connectors by yourself. In terms of data utilization tools, Panoply connects to any data utilization tool that connects to a standard JDBC, ODBC connection. We have a couple of companies that we work with that are kind of like our preferred partners, and I think you've seen in the demo, you've seen that we work with Looker. There are other companies we work with that are kind of like our preferred partners, but basically we do not believe in stopping any analyst or person that utilizes data from utilizing whatever tool he or she feels is the most adequate for their use.
Okay, great. I love that open model. All right, well, we're coming up on the top of the hour here, so we got to wrap it up. But before we go, I've got a giveaway here. Today's $300 Amazon gift card is going to go to Christopher Gartner. Thanks for being on today. We appreciate it. We'll be in touch, Christopher, to send you that gift card. Before you go, make sure you grab a copy of the handout here that's in your attendee panel and give that a look. Stop over at panoply.io to check out the solution here a little bit more. And thank you very much for being on, everybody. Thank you, Yaniv. Thank you, Elan. It was fantastic.
Thank you very much, everybody.
Thanks, guys.